Okay, so today is our last video before your big test on ionic and covalent bonding, and that is going to be the focus here. We've done these two types of bonding in two different units, and the challenge of your test is you're going to have to be able to tell the difference. So what we want to do today is talk about a couple differences. One difference we want to talk about is what they're made of. Okay? Second difference we want to talk about is what happens to the electrons. Third, and probably the most important difference that we're going to talk about is the naming, okay, and the formulas. That's going to be the one that you've got to really take some time and think through so that you don't get them confused and you don't get it messed up. So, let's do this one thing at a time. Let's start with what are they made of? So, very, very simply, we've talked about how to do this with electronegativity, but we're going to go back to simplicity. Ionic compounds are made of a metal and a nonmetal. So if you're given a list of compounds, okay, FeCl3, NaI, CO2, and you're asked which is ionic, which is covalent. Ionics are a metal and a nonmetal. Covalent, if you remember, are going to be either two nonmetals or a nonmetal and that special guy known as hydrogen. So, easiest thing to do here is use the world's greatest cheat sheet, as always. If I look at the handy-dandy, awesome, ever-so-wonderful periodic table, okay, and I go back to that list of elements that I just had, or excuse me, list of compounds, I had FeCl3. Well, if I look at my periodic table, there's iron, there's chlorine. Okay, the world-famous staircase is going right down here. So I know metals on this side, nonmetals on that side. So FeCl3, that's a metal and a nonmetal, that's an ionic compound. NaI is the next one we're going to look at. Okay, again, back to my periodic table. There's Na, there's I. That's a metal and a nonmetal, that's an ionic compound. Third one I'm looking at, CO2. Go back to my periodic table. There's carbon, there's oxygen. That's two nonmetals, that's covalent. Now this sounds ridiculously simple, but this is the basis for actually mastering the difference between ionic and covalent, is anytime you're given a formula to look at it. If you remember on your tie-dye worksheet, you had to ask, or you were asked, excuse me, about Na2CO3, and then you were asked, and I don't remember the exact numbers, but it was like C5H something, O something. I seriously don't remember what it was. So humor me, we'll pretend it was that. If I look at these two and I have to decide, is it ionic or covalent? Some of you got tripped up with this one, okay? But the thing you have to remember about ionics is not only is it a metal and a nonmetal, you also can have a polyatomic ion. If one of your polyatomic ions is there, then it's going to be an ionic compound. So CO3, that's an ionic, okay, or that's a polyatomic ion. Na is a positive, that's a metal. This is an ionic compound. But when I look at this guy, okay, CH and O, even looking at the periodic table, C, H, and O, there's no metal-nonmetal combination, therefore that is a covalent compound. That was from our tie-dye lab. So, number one difference, ionic versus covalent, what are they made of? Number two difference is what happens to the electrons. This is easy. Okay, in an ionic bond, your electrons are transferred. They are moved. If you are looking at a dot diagram of sodium and chlorine, okay, in an ionic bond, what's happening is this guy is literally leaving and going over here. And then the reason they're stuck together is he ends up with a positive charge, he ends up with a negative. It's an electrostatic bond. Okay? In a covalent bond, this is the most recent thing we've been working on, my electrons are all about sharing. So they are shared together. So if I have, let's do an easy one. Let's say I have, you'd think this would be easier to come up with one. Here we go, CH4. This time, nothing is moving, okay? Instead, I'm adding my hydrogens on so that they are sharing pairs, one from the other. Okay, so first difference is what are they made of? Second difference is what's happening to the electrons. And again, how do I know what's happening to the electrons? I look at the parts and decide what kind of bond it is. Third thing is where it gets tricky. You are going to be given just lists, okay? So I mentioned this in the last video. Let's say I gave you NaCl, CS2, SiH4, Fe2O3. I'm just going to give you blanks and say name them, okay? What that means you have to do is you have to think about, okay, wait a second, is this one sodium chloride? All right, that would be following ionic rules. Or is it sodium monochloride? That would be following covalent rules. So a lot of you guys know this instinctively because you know what NaCl is. But it gets a lot harder when we get down to things that you've not necessarily heard of before. So the trick with this naming, okay, this is my advice, is to first of all say, is it ionic or is it covalent? Okay, so go back to our first slide. Look at what it's made of, Na and Cl. If you look at your periodic table, okay, NaCl, that's a metal and a nonmetal. So I know that's going to be ionic. Now I'm going to look at the next one. I'm not even going to name it yet. I'm just going to look at the next one. CS2. Okay, there's my carbon, there's my sulfur. That's two nonmetals, that's covalent. SiH4. Silicon's over here, hydrogen's up there. Hydrogen is not a metal, that's covalent. And then Fe2O3, there's my Fe, there's my O, that's ionic. Okay, that's the first thing I'm going to do. I haven't even written anything in the blank yet. Okay, it's going to help you from getting confused. So, my advice at this point, and we'll come back to this slide, is to start with the covalents, because covalent naming and formulas are so much easier. They use prefixes. Once you've identified it as covalent, your life is so simple. Use your prefixes and don't do anything else. Don't think about it, don't crisscross. Don't do anything besides these prefixes. So going back, CS2. Well, the prefix on the first one would be mono, except I got to remember I don't put mono on the first one, so that's carbon. And then I've memorized the prefix for 2 is di, and it still has to end in "ide." So carbon disulfide. Now I've got to do the same thing for the next covalent. I'm not even looking at these I ones, okay? I'm pretending they're not even there. SiH4, it's covalent, I already said that. So there's one silicon, and we don't put any kind of prefix on the second one. And then H4 would be tetrahydride. Okay, so any of them that are covalent, okay, you've got to do those first. Let's say there was another one down here. H2S, went to my periodic table, decided it was covalent. I would go ahead and skip down and do this one. Dihydrogen. And then the biggest mistake a lot of you guys made is you kept forgetting the mono on the second one. So you do use mono on the second one, monosulfide. All right, so do all your covalents because covalent is easy. Yay! If you're going the other way for the record, covalent is freakishly easy. If I give you dihydrogen monoxide, which I would actually like a glass of right now. I'm a little thirsty. When I'm looking at that one, okay, it's hydrogen, it's oxygen. Looking at my periodic table, that's a hydrogen and a nonmetal. I don't even really need to do all that. If I see prefixes, I do what I'm told. Dihydrogen would be 2, monoxide would be 1. Okay, I really don't have to think that much about covalence. Even when it's something ridiculously complicated like, you know, tetracarbon. Let's see, what's a good one? Tetracarbon octahydride. It sounds so complex. Dude, carbon is a C, hydrogen's a 1, tetra is a 4, octa is an 8. Done. So always do your covalents first. They're easiest, so focus on the easy first. What I'm left with now are my ionics, okay? So, when you have ionics, the first and easiest thing to do is ones that are not transition metals. Anything that does not involve a transition metal or tin or lead is simple. You name the first one, you ide the second one. That's it. And if you need help remembering that, just, you know the name of NaCl. You know it's sodium chloride. It's not sodium monochloride. You know that. So focus on that one that you already know. So if it doesn't involve a transition metal, tin or lead, piece of cake. Just name it, all right? No prefixes. And this is why I say to separate them, because once you get all your prefixes done, you can tell yourself, okay, I'm not using those stupid prefixes anymore. The last thing you've got to focus on are your transition metals. Okay, so with ionics, if you have transition metals, this is when you have to do the Roman numerals. So you can do the split if you want, where we do Fe2O3, we split it, we look at the periodic table, oxygen's a -2, there's 3 of them, which gives us -6, whole thing has to be 0, this side is a +6, so each iron has to be a 3. Or you can do the other way I showed you using algebra, okay? 2 irons plus 3 oxygens have to equal 0. I know from my periodic table that oxygen is a -2, so that gives me 2 Fe's minus 6 equals 0, 2 Fe's equals 6, and Fe equals 3. These are the exact same thing, just done in a different way. But I know based on this that iron has a charge of 3. So that means I say it is iron 3 oxide. There is no prefix. I'm not doing covalent. You can use different colored pens if you want, okay? That's up to you. You just have to go and split them between covalent and ionic, and then look at it, okay, one thing at a time. For ionics going the other way, it's pretty simple, all right? If you are given, let's say, potassium chloride, all right, this is when you crisscross, okay? So potassium is a 1, chlorine is a 1, that's KCl, all right? If you were given lead 4 oxide, again, you crisscross. So Pb is a 4, oxygen is a 2, so I get Pb2O4, which we know reduces down to PbO2. So the trick between distinguishing with ionics and covalents is identify which is which first, okay? Look at what they're made of and basically break them down into what's what. Remembering if you see a polyatomic ion, it's going to be ionic. And then do one at a time. Do all your ionics, okay? But do all your covalents first. That way you get the prefixes out of the way. Good luck on your test. I know you guys are going to rock it.